Okay, I think I'll get started on introducing myself while people are moving in. My name is Bo Thorsen. I run Thorsen Consulting, which is a Qt expert consulting company. And if any of you have some need for extra Qt developers, come see us up on the first floor up there, just next to the bathroom. Convenient. And there I can actually show you one application that implements a lot of the things I will talk about here today, which are the model view classes in Qt. Now, I have to tell you, I'm going for the most boring slides award this year. Hopefully, you will actually listen to what I say instead of just sitting there reading that. Well, you'll be done so fast that. So why these model view classes? They're one of the things that have really sparked a lot of discussion in Qt4 because, quite frankly, they're difficult. When back in the Qt 0.0.1 days all the way up to 3.3.6, it's always been QListView and QListViewItem and QTable widget. And it's worked, and we've been using it, and for small examples, it was actually fine. But if you had ever had some project that had been going on for years, you would realize that these classes led to code that was extremely hard to maintain over time. These things are completely different. They are difficult to set up. They take a fair amount of work to get going at the beginning of your project. And that's annoying. You want to start and you want to have something going. You want to have an application you can run and see stuff very fast. But I'm here to tell you, take your time and get these things done, because these classes are the best thing in Qt4, if you ask me. And that's not because I'm a consultant and they generate a lot of work for me. It's because I actually really like these classes. And the reason for that is not obvious when you start out, because they are difficult to get started with. But as soon as you really start using them, start using sorting, filtering, and figure out how to do all these things, they are amazing. One of the things they force you to do is to really separate the responsibility of code. Those of you who have an education in computer science will have heard all your teachers say this. You should do this. And, well, some of us have really made an effort to do that. And these things force you to do it. You cannot put any kind of control code inside the GUI. Usually, we don't care about the GUI stuff. That's the Qt classes. What we are interested in are really the model. That's where our main focus is. And it's also where my main focus today is going to be. So let's just take a simple example. I nicked this from the Qt example, so some of you might have seen it before. Now, imagine that this is a complete Qt code. There we have a main Q application app. Down here we have return app.exec. That's it. No more code. We have a full application here. It will actually show you a tree with all the contents of your hard drive. It's not more code than that. So let's take a look at what we have here. We have two classes that play together. We have the model class, this one, and we have the view class. So on the view class, just set the model. In this case, you have to tell you that you want to go to the root of your hard drive. This is Unix. It could have been C:\\, and just show the view, the widget. That's it. Another simple example, just as boring. This one is a fantastic application that will show two lines. One of the lines is 1. The other one is 2. Exactly. There was one very perceptive one down here at the front. Extremely boring, right? But it's, well, I use two of the the models that, what? Oh, I thought this had broken. This QStringList model and the QDeal directory model, they're part of Qt, and you'll never use them. Maybe the string list model from time to time, but what you'll usually do is implement your own model. What you will use are all the view classes. You have the list view, you have the tree view, the table view. You'll use these constantly, and they're usually enough. Now, how does all this work? What is it that binds these two classes together? That is the model index. This is one of the places where discussion have really been sparked. Why can't we just use the old way? We had the tree view item, and we were happy about it. We had a pointer, just give that object to the view, and it would be shown. Well, the problem with that is, why generate an object when you already have the data lying around somewhere? These model indexes are not generated, are not used before you actually want to show something on the screen. So if you have a table with 30,000 rows, it doesn't generate 30,000 times the amount of columns QModelIndexes. It only generates the amount of QModelIndexes that you're showing right now. And that's one of the reasons these implementations are actually very, very fast. Now, this one is also where the limitations of this system comes in. If you have something that cannot be shown or given enough information to tell by a row, a column, and a parent if it's a tree, then you cannot use one of these model classes. So if you have something else, you have to go code the old way, for example. You can still use that with a Q3 widget. But if you can, which often you can, then go and build your own model, start using these indexes. You won't regret it. Now, it's obvious that if you just have something like the QStringList, then we're not going to use the column, because there's only one. We're not going to use the parent, because it's not a tree. It's just a simple list of data. So it's not all of these three that are actually used for every single view. It might be used in all of the models, but it's the view that decides which one it actually wants to use. One of the things that's really difficult to get in here when you start out is, why on earth can't you just make a QModelIndex? You cannot do that because the QModelIndex can have some private data that you, as the user of the model, are not allowed to do anything about. It's something the model can set inside it and just keep it private, some internal way of accessing some more information it needs. So you have to ask the model for an index. And that's annoying, and it takes some time to get used to it. Once you have an index, you can ask for the next one, or its parent, or one of its children if it's a tree. So let's try one of the things that we do all the time when working with these classes. We implement a very simple table. In this case, I have the data down here. It's just a Q pair, Q string, and an integer, and we have a list of them. Very simple little model. We have, obviously, we have two columns, so the column count will just return 2 because there is a string and an integer. And the row count will just return the amount of entries in the list. Simple enough. So the real fun begins when implementing the rest of these. This is not real. Oh, if I shoot it, then it actually sometimes works. These these 5 are the ones you need to implement to make a custom model. You subclass QAbstract item model, and you implement these 5 ones. Then you have a custom model. There are other things you can do. There are some cases that's been implemented for you, a QAbstract table view QAbstract table model that you can implement and it basically all you need to do is return the data. There is also a QStandard item model that you can use to implement it, and these implement some of these 5 and possibly some more. So let's take a look at the implementation of these 3 here. Now, you'll see a lot of code on these slides. I don't care much for text. I assume that you're all coders. If not, then you'll have a lot of fun here. So, the index function. Actually, in this case, we are so fortunate that we have a protected method called createIndex that we can just give the row and the column number. This is not necessarily the case. This is the method you want to use to store that special data inside the model index if you need to do it. You can put an integer or a pointer in there if you have that need. But usually, if it's a table or a list, you just call createIndex. If it's a tree, then you have to worry about where in the tree are you. And for that, the last of the arguments to the function is the parent to this current row and column. I don't have a lot of space on this thing up here, so you have to bear with me on the shorthand notation for most of it. This QMI is a const QModelIndex reference. The parent method is very simple because we're not trying to build a tree. So every parent is always just nothing. And for that, you just return an empty QModelIndex. That one you actually can just instantiate, but doesn't really help you a lot. So data is the one that looks like it actually does a lot, but it doesn't. The only thing we do at the beginning, if this was working, is to check if this is something we can actually do anything about, and if this is about displaying. If it's not, just return nothing. If it is, then if it's the first one, we take the string. Second one, we take the integer. And that's it. These roles, there are a lot of roles that Qt will ask of this. Usually, you have to implement display role because this is the one that's actually going to be showed in your table. You can also implement edit role if it's something that you can edit. You can. There is a tooltip role. There is a status hint role. There is font role and decoration role, which is icons. A text alignment role. Now, if someone can tell me what something about showing these strings text alignment role actually needs to do in a model, and I'd like to hear it. That's the only part I'm really not happy about with these. But, well, let's not stay with that. So basically, in this case, all we do here is to just show the data. If I just go back here, I will just make a brief statement about editable models, because I'm not going to do anything about those in this. I don't have the time to do it. If you need to do a model where you can edit the data, you have to implement the flags method and the setData method. And that's the only two. And the only thing you have to do in the flags method is that if it's actually valid data that returns on this model index, just says, yes, you can edit this one. Okay, enough about editable stuff. So, a fantastic application we have written here. We have a custom model. I just put it in a QTable, like in one of the first slides, and put in pairs of the month names and the month number. Fantastic, isn't it? So, on to a lot more interesting stuff. Sorting and filtering. Now, this is the part where things start to get fun. I mean, what you saw just before is actually not something that's going to make you jump for joy, but this might. If you want to have your table sorted, that means your users can click on the header and it will sort the rows according to something, some comparison. This is not something we shouldn't do. I mean, it's reasonable, right? People want to do this, so let's give it to them. And it's really easy. We have the QSortFilter proxy model. I don't know who came up with that name, but I think it's a very catchy name that we'll all remember from now on. And the only thing you do is to make one of those, give it your model, and then give that sort filter proxy model thing to the view, and you're done, in theory. We'll come to the theory part later. But that's the idea. For filtering, there are a couple of things you can set on this sort filter proxy model thing. And you can say, I will filter out everyone where the second column says falafel, or where the first column says 1, if you don't like 1. It has some, you can set regular expressions, or you can say, I don't really want this column at all. So you just show the month names and forget about all the month numbers. And suppose you have some columns that are really odd things in there. A column that shows a color. How do you sort a color? Well, I don't think you can do that, but at least you can in your code. It's not a problem at all. You just override less than on a QSortFilter proxy model, and then implement whatever you think that sorting colors should mean. Yeah. So let's take an example. We want to sort this amazing little this little application we did just before with all the months. So we take a table model, the one we just made. We make view. This is a QTableView. That's sortable stuff. Come back to that in the next slide. We make one of these, the QSortFilter proxy model sorter, and we set the source model on it. That is this guy. Set the model on the view. Now we tell the horizontal header, yes, you want to be clicked, and you want to see which one is actually doing the sorting right now. And for some reason, I decided to do this again, and I can't explain that, so forget it. And that's all. There is only one slight problem. It doesn't actually work if you use a QTableView. And the reason for that is a bug. Qt doesn't have bugs, right? Well, this one does, unfortunately. Supposedly, it should be fixed in 4.2, and does anyone know if that's the case? Sorry, but I didn't check. Don't know. They claimed in the bug tracker that it should be fixed for 4.2, so let's assume that's true. But if you're still using 4.0 or 4.1, this is the fix. Look at it, forget it, download it from my website if you want to actually do this, or use 4.2. Sort by column is a method. It's actually a slot on QTableView. You override that, and you figure out if we should be ascending or descending, and then you tell the horizontal header to set the sort indicator and tell the model to sort on the column and in the order you figured out. Boring, but necessary. Now, the real fun is that this is not a virtual method, so you can't really override it, but you can do it, and then you can disconnect the signal on the view and then connect it to this one again, and then it works. And voila! Sorting! See? Isn't that good? Now, if you forget the last slide, and we assume that it actually works in 4.2, this is incredibly easy. You made a small model. It has custom data. You have a table view that shows all this. And what is the code line, amount of code lines I've done? About 25. I think that's pretty amazing. And of course, if you click these, then it flips up and down. Now, another thing you could do with the less than is a good example here. for example, what if you want to click on the first column and you still want to sort on the column numbers? Now it's a string, so the less than for strings does the obvious thing. It just does a normal dictionary sort. So it will sort December in front of November and November in front of September and so on. And that's not what you want in that case. So you could override less than and do something that checks on the names of these. It's a horrible way to do it, but, well, you could do it. So, filtering. This is the way to get rid of the falafel rows. We don't have a falafel month, so we pick on the number 2 instead. So the only thing you do if you want to do some custom stuff that's not done with the simple methods on the QSort filter proxy model is these are the ones where you could set regular expressions. And if not, then you could override one of the filter accepts row or filter accepts column. Filter accepts column, just get rid of entire columns, obviously. Filter accept rows is usually the one you want to do something about. Filtering always works on rows. There is no way to say I want to get rid of all the columns that have falafel. So instead, well, all of our data is on rows, and I don't know if that's a valid assumption. I've been trying to figure out, and I think for almost all models, we actually do use data sorted in rows. So I think it's okay. I'm not completely convinced yet. Just because I didn't yet find a case where it's bad doesn't mean it doesn't exist. But I can't talk more about this, much more. That one. Filter accepts row. Just check, does this have a row where the first column, the one with the numbers, is 2? If it is, don't show it. If it isn't, then we want to show it. And as you can see, is another fantastic application. I have them coming. You will see that it doesn't show the second row, the row with the number 2. So this is actually real code from one of my projects that I've been paid from. And I think it's obvious why people pay me to do Qt code. It just shows a table in a MySQL database. I've set up the database connection, so I've called the QSQL database, I think it is, and said, yes, I'm username this, I want to connect to host name localhost, and I have password that. But once all that boring stuff is done, then this is all you need to do to show everything that's in this inventory. In my stock inventory. I don't have a lot of stock, so it's boring, but supposedly the guys I work for, they do. So if you put this in one of the the great applications from one of the first slides, then you'll see these contents. Now, unfortunately, that's not what they wanted, because the way they wanted to have this database is that they wanted to have how much was sold and bought. So when I had all these different rows in there, it will say I bought 50 shares, I sold 20 shares, I bought another 30 shares, and so on. That doesn't really help you showing how many do I have right now and what are they worth. And that was the question they had. So I could have made some code that said, well, okay, let's take all these rows, we'll just add them together in the model. Or I could do the other thing. I could write the 10-line SQL script that does it in 1 line, and thought that was a lot more cool, so I did that. So instead of doing this, I have to do something with a custom select. The one on the last slide that just showed an entire table. This one shows stuff that comes from 4 different tables. It sums up stuff and it filters it out if you don't have any more of those. I mean, if your stock count is 0, Shouldn't be less, hopefully. So if you do have that situation, you want to show something where you have a custom SQL select statement, then I suggest to you that you do this. You implement a refresh method. The reason for that is that these SQL data models, they cannot automatically update from the database. You have to do that by hand. And I hate that, but there's no way around it. There isn't a single database that's implemented with these usual connectors that will keep a connection to the database and push changes to you. You can do that, of course, but it's not the normal way to do it. You have to say the user click of refresh button and fire it off again. And the simplest way to do that is just to have a slot that you make called refresh. This is not a Qt thing. This is my recommendation to have it. So in the constructor, I just call refresh, and it does all that weird stuff down there. So databases are not a big issue here because they're so simple to do. So I won't spend a lot of time on them. That's not because it's a small subject, but these two slides actually pretty much show what I've been using on SQL databases for the last 1.5 years that I've been doing this. It's not more than this. It's that simple. Sometimes you do just take the data from the database and put it in memory and then work on it like I did on the one with the 2 columns with the month and the month number. But that's not usually what I tend to do, because why do that when I can keep it on the database as I can do here? So let's move on to another topic, something that's incredibly difficult everywhere, right? Drag and drop. Anyone actually try and implement drag and drop in a Qt application before? Cool. A lot of you did that. So you know that it's not something you do in 5 minutes, right? Well, yes and no. If you use one of the standard models that actually can do this, then this is all you do. You just take a view and say, yes, I can drop on it. Yes, I can drag from it. And I really want to show when someone wants to drop something on me. And that's it. You just show it again, and you have drag and drop. Now, as I said, what we usually do is to implement our own model. Actually, that's pretty much always what we do, except in the cases where from the first 2 slides. So this one and the next one will show you all you need to do to have a model where you can drag from. First of all, of them is the flags. This was the one that was used when you wanted to make something editable. That doesn't mean you can eat it. It means you can change it. In the flags, you also have to tell it if you can drag and drop on these items. Now, it might look like a lot of code, but that's just because this is such a bad way of showing code. I'll try this one again. So first of them, this is a string list model I'm working on, so I just take whatever is usually returned, and I add the drag and drop stuff to it. So if this is a valid index, that means do we have something right now that's actually in the string list? If it is, then we can drop on it, and we can drag from it. Plus, we can do whatever it is. If not, then all we can do is drop on it. This is the case if you're outside the list of items you have, or if you are in between them. Then it's false, and you go down here. In that case, you can obviously only drop on it because there is nothing to drag. So, if you want to drag something, you have to give the data. And in this case, we're using a string list, as I told. So all we need to drag is a few strings. So the first thing we have to do is tell which Mimetypes can we actually return. I'll forget this again, I think. So in this case, it's just text plain. You could return several different types of Mimetypes here if you want to. In this case, we only have one. And the second method you have to implement is the MIMEData, which actually packs all your data inside a QMIMEData object, which is the object Qt uses to move data around when you press the mouse and drag and drop. So I have an indexes to strings here. There are 5 points for anyone who can figure out what that does. And okay, for the rest of you, I'll tell you. It just takes the indexes and returns all the strings that we want to currently drag. For example, you choose a couple of them, start dragging. So we make a new QMIMEData, set this text on them. It's just a single string, so we have to join them and hope none of them actually return the backslash n, and return this MIMEData. And some of you will probably wonder what happens with this new QMIMEData. Did I just lose a lot of memory? No, you don't, because Qt handles it from here. So do not give it something on the stack. You cannot do anything about that object. Make a new one, give it to Qt, and trust that it will actually be deleted. It will. So, what if you have that odd thing, the one with the colors, or, I don't know, falafel, whatever. So you want to have some custom MIME type. Not difficult. You do exactly the same as just before. Now, well, almost exactly the same. You make a data stream, and you tell it, I want to write into these qbyte array MIME bytes. I really want to use this. Come on. See, these are the bytes we're going to ship out. This is the stream we use to fill in the bytes. And we just go through all these indexes. If it's a valid one, put this data inside the stream. And obviously you have some data function that returns the right thing to put inside a QData stream here. Again, make a new MIMEData, call setData, the MIME type, and the MIME bytes, and return. And that's it. That's all you need to do to implement dragging from your custom model, even if it has custom MIME types. Now, it might be that your data is actually on several different MIME types. Could be that you have an image and you will drag it as a PNG file, and you will also just have it as ASCII art. I love ASCII art. It's so naive. So you make one that's a text plain, and you make one that's an, what is it, image/PNG? I can't remember. You get the idea. And you just make 2 data sets and put on this one. So you call setData twice. So if you want to drop on the model, another nice thing to be able to do, it's pretty much the reverse. Now, first of all, whenever you do call it, you implement the drop MIMEData thing here. You get the MIMEData, that's the object, get a drop action, and a place where you got this, hey, it works, where you want to drop this. So you get the position inside your table where it should be. Now, the first thing you do is very obvious. You have to see if this is something you should actually ignore or not. I have no idea why, but do it. Anyone has a good explanation for this ignore action? Didn't think so. So another check, is this outside our columns? What does that mean for a single list? I don't know. Return false. We can't do this. So if we're past these 2, then we're into the area where we actually will accept this drop. So we take the strings that's in there, we do this the split on this one, and insert all the rows for each of them, set data, blah, 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 and say, yes, I could do that. Now, yes, you should do that. In a real application, you should test it. Does this drop actually contain data? Does it have data? Yes, you can test. You get a string list on of the MIME data. That's the Mimetypes that this drop contains. But in this case, it's not necessary because the data text will just return an empty Q string in this case. And when we look at this, the code will work. We just insert nothing. So in this particular case, I can get by without it. But in every other case, I should actually check it. Now, it is a safety thing because Qt should see that we told it we can work on text plain and app/cool. So that's the only thing we want to have dropped. But you do have a problem if you can drag two kinds of MIME types, but you can only drop one of them. Then you should check this. You can also, there is some method, and I cannot remember it. I think it's called accept MIME data, where you will be asked, will you accept this drop? And before the user dragging actually sees this mouse thing that that looks like you can drop on it, if you return false on that one, it will say no, you can drop here. And if you do that, then you don't have to check, because then you know that it's never going to happen. So, last slide. I'm really fast today. I used to talk a lot, but obviously that's no longer the case. Now, if you want to drop custom data, that's it's exactly the same as what I just did. It's just a lot more code, and I tried to write it down on this thing, but that didn't really work out. So I decided to just give you a recipe. And here's today's assignment for tomorrow, and you all have to come back and show me that you did this. You just figure out, is there a MIME type in the drop that we understand, and you take the data in there, just like we did here. Here we take data text, another 5 points for the ones who can figure out what the method is called that takes data out of there. So you get a qbyte array, and the only thing difficult is what do you do with a qbyte array that's been dropped on you? Well, if it's a PNG file, then give it to the QImage thing and make it decode the PNG. If it's text in some odd format, then you have to decode it yourself, perhaps. But that's the only thing. And then you just insert the rows exactly like the code just before. And that's it. That's all there is about drag and drop. It's all done in the model. The only 3 lines of code I did on the view was this set accept drops and set accept drags. And that's something you can click in Designer and say, yes, this view actually supports this. It's all about the model. That's the one that decides what you can drag and drop and what actually happens when you do it. So again, this is one of the places that shows how little we actually work on the views that Qt gives us. It's all the model, and you will be implementing a lot of custom models once you start really using this stuff. So I'll tell you a little bit about an application that I wrote, and I'll just show this while I do that. It's an application called PlayLink that I will demo for you if you you know where to go by now. The Thorsen Consulting booth. It's the one. Very nice place, friendly people. This application was a project I did for an American company, and it's about controlling online games. The idea is that online gamers, these 5 guys, they want to play a game where they can shoot each other. That's how they are. We can't help it. And the problem is, how do they figure out that this guy actually wants to shoot exactly these 4 guys? Well, they have to find each other on the place. They have to find some server to run this thing on. And that's what Playlink is all about, to make that as easy as possible to find other people and shoot them in games. So we did a system that has AIM in there. So if you have an AIM login, then you're already set up to use Playlink. And we have one big model with all your AIM bodies that you know in there. This model is a big table with the rows are obviously all the bodies and buddy, you know, with the U, friends. And the columns are all the different things that a friend can have. Is he online? Stuff like that. So we have one big model, and we showed a lot of different places in this application. The first one is the easy one. You have a list of all your friends that you want to write something to. It has a chat in there, the AIM chat. So you can double-click one of your friends, and you can chat with them. You can group them in groups. And obviously, how do you do that with this sort filter proxy model? We have one of the attributes on a friend is what group is he in. So this group, we just have a combo box. That's a list of all the groups we know, another model in another view. And this combo box, whenever you choose one of your groups, then it will tell the list of friends, you should only show the friends that are in this group. That's a simple filter. It's very simple. We just filter out all the ones that are not in this group. So, easy. Now, once you choose a game, say you want to play some Half-Life, you click on Half-Life and you go into a small screen where you can chat with all the other guys who want to shoot each other in Half-Life. And then you say, I want to start to build a server. So the SCI servers will run a Half-Life server, host a Half-Life server for you. And you get into a new chat room where you can drag all these friends down into an area, which is the invitation area. So these friends, the AIM body model has drag and drop in there. We have two places, 2 views here. One that has all the list of your friends and one that's all the invited people. So we drag one down into this area, drop it, and we show all the ones that are invited. So we have another sort filter proxy model that shows all the one that's currently invited. We even have an icon on them that shows if these accepted the invitation or not. And when I first started out in this project, I hired a freelancer in US, and he was all, these model indexes are crap, we should all use pointers, and they're difficult to work with, and by now he thinks they're as amazing as I do, because we started using all of these filters and sorting and drag and drop, and we figured out just how powerful it is to just have all your friends listed in one single model and just implement a lot of different filtering on them. Another example from that application is that we have a list of about 2,500 games that this system knows. Now you cannot scroll through 2,500 different games to find the one Half-Life that these people want to shoot each other in. So we have another set of filterings where you can choose on the first letter in the name of the game. You can choose on, have I installed this game or not? Can SCI host this? Can I run it on a LAN at home? Can I run it on a LAN system that this implements that connects to other people? It looks like a LAN, but it isn't. And then a lot of these filters just give you simple ways to find the exact game you want to play. There are other models in there. We can drag the friends down into a VoIP area and so on. So once we really started using these things, we got so much that was just pretty much automatic for us. We just filtered on a few things, and that was it. Every time a buddy updated his name in the AIM system, AIM told us, and we just updated that single place in the model, the original model with all the friends that had this information, and it would propagate out to all the different places. We used this through filters and proxies. It is absolutely amazing once you really start using them. And I don't know if you've noticed, but I'm actually pretty happy about these classes, so I'll recommend that you use them. All the different code here, I know you're dying to get your hands on all the application I've shown, so I put them on my website. It's on the software. There are some other things you can download and play with in there, but all of this stuff is in there. It's not rocket science, but at least the drag and drop code is probably some code that you actually might want to see again. So you can look in that. I think you should have the slides on the CD. Maybe they dropped that. Well, you can download it from there, and at least the QTable workaround, that's handy to have. So you can go there and download it. I don't mind the extra traffic. And that's about it. So I will take some questions.